Matthew too, I think, right? Freaking website is such a pain in the butt. All right, so just kind of give you a big heads up, big overview of this course at a glance. This is a poster that kind of shows you the different units and things. We've done the living world ecosystems. We're about to do biodiversity, and we do populations, earth systems and resources, which we've kind of already done a little bit of, land and water use, energy consumption, energy resource and consumption, and then pollution, and then global change. Global change you've already done a little bit as well. So you know, we're trying to roll through, and these units match up with the tests on AP Classroom. I'm really, you know, not using the test to try to beat you up. It's all about making sure that you know what you're doing and heading in that direction. My little picture thing with my face. Oh, start videos. My bad. All right, so I can be able to see when that happens. But yeah, test tomorrow is going to be similar to your ecosystems test that we had earlier. 30 multiple choice questions, 1 essay, planned for class period amount of time to work on it. Go ahead and get used to that time, about 1 minute per question and about, you know, 15 to 20 minutes on each essay, because that's the time you're going to have for your AP exam in May. This AP exam is historically one that people do poorly on, not because it's hard, but because it seems easy and people just show up thinking, I'll just make 100 on it and roll. If you prepare, you'll be fine. I'll give you as many tools as I can to help you prepare. And that's why I'm doing these AP Classroom tests, because this is similar to what you're going to see on the AP test. So, you know, do your best, use your resources to help you make the best grades you can make on these AP Classroom tests, and then review the things you did wrong so that when you see a very similar question on the real AP test, you'll be rocking and rolling and be able to knock that out. Okay? Well, so no. Traditionally is pencil and paper in the classroom, and you write out your essay longhand and things like that. Obviously, last year things were different. They were kind of put their backs against the wall, and all they did was do 2 essays and have that count for their grade. Now, this year they're saying they're not going to do it like that, and there will be multiple choice questions. Whether or not you're doing it digitally or pencil and paper, we'll see.
Oh, wait, so there is multiple choice questions this year.
Yes, I misspoke on that earlier when I misread their announcement when they were doing that.
Do you know around how, is there still the essays though?
Yes.
Do you know around how many?
The traditional test is 100 multiple choice and 4 essays, I believe. But it's like you have it's like 100 minutes. 100 minutes to do 100 multiple choice, and then like 100 minutes to do 4 essays. And then my numbers may be a little off, but something like that.
That's a lot.
Yep.
It's the same thing for you. I said to just read the question.
Well, and then, you know, you're going to see some questions like that tomorrow. You know, that's one of the skills that you need to get is, you know, nailing the questions you know you're going to get right, and then coming back to those questions you're spend a little bit more time on, and then being able to, you know, glance over something and figure out what the question's asking without necessarily having to read the whole book that it gives you before multiple choice question. Okay, so let's just go through this, talk a little bit about some multiple choice questions, and then we'll talk a little bit about the essay. I'm just going to kind of hit big things you need to understand to help you on the multiple choice questions. different types of species and their roles in the ecosystem. There's a question on the APID test last week that a species that has a greater role than its biomass in the community. Anybody remember what that answer was?
A keystone?
Very good. So a keystone outside of this class is if you look at a bridge or a stone arch, you'll have a bigger stone in the middle, and that stone holds everything else together. And if you took a sledgehammer and knocked that stone out, the whole thing would fall down. Keystone species is that for an ecosystem. So you have, usually for a keystone species, you would need to have something that affects things lower than it on the food web and higher than that on the food web. And so the example we used in class last week was the bat in the durian forest that pollinated the durians, ate the durians, spread the seeds around, and provided a food source for things higher than it on the food web. So think about things that are important in the ecosystem, both up and down the food web. Species that exist on multiple stratification in the ecosystem. We used the example last week of squirrels. Hello, Kylie. We used the example last week of squirrels that in North Carolina affect the ecosystem in the trees, but also affect the ecosystem on the ground. So think about things that move around, things that affect different things in the ecosystem, and if you killed them, would be pulling the pin on an ecosystem and you completely change it. Make sense? All right, rolling on. A lot of questions about evolution and how evolution works. Why do the finches on the Galapagos Islands have different sized beaks? Go ahead. Yeah, adaptation to what? Go ahead. Yeah, so a population of finches sometime a few thousand years ago, a million years ago, depending on how you count, showed up on the Galapagos Islands. And since there were so many finches and not as many food sources, you had to kind of split up, and this group started eating this group started eating that, and over a long period of time, you ended up being just completely different species. That's a booby. Maybe there is, I'm not sure. Cody asked, was there a bird with blue feet? I have quite a few questions on the test tomorrow that are just, can you read a chart? So be careful, read the chart carefully. If at any time, I'll try to remember to leave the Zoom open, remind me if I forget. And at any time you're taking this test and you see a question where you don't understand a part of a chart, feel free to call me over. I'm here, we're learning, and I'll be glad to work with you, especially if you're here in the room. But if you're on the Zoom as well, I'll be glad to do my best. And I can flip to any of the questions and read them as well. One of the ways that we talked about measuring health in an ecosystem is biodiversity. Biodiversity means what? Two things. A bunch of species, so that's called species richness. Go ahead. Well, that's a bunch of species. But you can't just have a bunch of species, because what if you have 30 different species, but 99% of what you see is one species? For example, a cornfield. A cornfield, if you go into a cornfield and start counting all the species, you'll probably find a bunch of different species. But most of the species in the cornfield are going to be corn. So it's not the most biodiverse ecosystem in the whole world. So not only do you need to have a whole bunch of species richness,
It has to be big numbers of different species.
Species evenness. You need to have an even number of different types of species. So that's how you look at a healthy ecosystem. If you show up in an ecosystem and you find very, very low biodiversity, what can you tell about that ecosystem? Go ahead. It's not very rich, but so I show up, for example,
species dominates the rest.
Sometimes the species can dominate the rest, but let's say that I go to a swamp. I go to a swamp, and I find a species, I'm not going to give a number because the Shannon-Weaver index and all these ways that they measure biodiversity is very, very complicated. I'm not going into that. But it has, by my measure that I'm taking, it has very, very high biodiversity. And then 2 years later, I come back and I find the biodiversity is half as much as it was before. What can you tell me? Is that good or bad? Yeah, it's bad. Something has happened to completely change that ecosystem. Something has happened to adversely affect that ecosystem. Maybe someone built a housing development that drains into the swamp. Maybe the farmers around the swamp started using some type of fertilizer or pesticide that affects the swamp. Okay, so something's happened to adversely affect that swamp. Make sense? All right, rolling on. Obviously, you guys understand what I'm looking at, right? As I'm talking. Yeah. We already talked about species richness with biodiversity. Understand the service that biodiverse ecosystems can do for us. It's like, even if nobody lives in the swamp, that doesn't mean the swamp is useless for us. Or can somebody explain what I mean? Even though nobody lives in the swamp, that doesn't mean the swamp has no purpose and serves no function for humans. Go ahead. It could be food and water sources. Others? What's primary productivity doing? Food, but also what? Yeah, everybody with me? You know, even though nobody goes in the swamp, it's one of the most biodiverse ecosystems in North Carolina, and the primary productivity is putting a lot of oxygen in the air for us. Thank goodness for that. Okay, and also the flip side of that would be exactly, it's filtering out carbon dioxide from the air. It's keeping water where it belongs as opposed to flooding our houses. You know, you guys might not be quite old enough, but you're right in there, that region where maybe you are old enough to remember about 10 years ago or so when they clear cut the swamp around Continia Creek, around the highway, where like you drive over the highway going to Kinston, or either leaving out of Grifton past Highway 55. You see both sides of the road. You kind of have the creek, a line of trees, and then a bunch of clear cut area. Okay, that's the dumbest thing in the world. I'll tell them so to anybody to their face, because trees hold water.
And they hold ground together.
Prevent erosion and hold water. You want flooding? Cut down your trees. And then, you know, since that 99 flood and then that cutting down trees, Griffin's kind of flooded two more times, but nobody asked me. All right, so just understand that if something says a cultural service, what kind of thing are we talking about? A cultural service. So not a biological service, but a cultural service for humans. Yeah, like so having some religious importance. I listened to a podcast last week about Mount Rushmore. And the way that the mountain had, I mean, right now it serves a cultural service for United States citizens because you can look at your history and blah, blah, blah. But before that, it was performing a cultural service for the Native Americans in the community because of the religious importance of that mountain. And so cultural service, you know, a lot of times we forget that ecosystems can have a cultural importance. Yeah, we kind of already talked about that. If you cut down a bunch of trees, you're worried about increased carbon dioxide in the air. I've got 3 or 4 questions on island biogeography. I didn't really talk much about it. I had a slide up in my presentation about it. I talked about it kind of quickly. Islands are neat to study because they're small little ecosystems on their own, and you can really tell what's going in and what's going out. And one of the big things that the questions to talk about is if you want, what's going to be different about an island that's 100 I don't want to go say 10 miles off of shore versus the island is 25 miles offshore. What could be different? I dig it. There could be less biodiversity, but more things living because they're been kind of separated for longer. I dig that. The big thing though is that migration is different. The odds of you getting something to fly from the mainland or getting migration from the mainland is much better the closer you are to the shore. So the size of the island matters because you can have more biodiversity, and the distance from the mainland because you can have interaction between the mainland.
Is that like a lot of times if you're on a boat or something over the land because they're tired, so they're flying forward?
Sure. What does anthropogenic mean? Anthropogenic activity. We don't talk about it as much in this class, but in anatomy class, we talk a lot about word origins. Anthro.
I'll know that next semester. I'm here for anatomy next semester.
If you're studying anthropology, what you studying?
History?
Yeah, history of humans. Human history, human origins. Okay, so anthropogenic, what is genic? Not good try, but just the root word genic, like Genesis. The beginning. So anthropogenic, not necessarily the beginning of humans. If I said that the cause of the decrease in biodiversity in the swamp was anthropogenic. There you go. It was caused by humans. Okay, so I mean, this is an easy multiple choice question I'm looking at, but the challenge is, do you know what the word anthropogenic means? So anthropogenic, you're talking about something humans are doing to affect an ecosystem. Make sense? Carrying on. Another one that you got to be able to read a chart about. I feel like it's pretty easy. I'm not really going to say much about it. If you got any trouble reading the chart, let me know. Same thing on that one. I tried to pick the chart ones because I feel like they're easy, and I feel like I want you to get experience answering easy questions on charts. Got a handful of charts that talk about succession. And you have the APID question about succession. What's the difference between primary and secondary succession? All right. Somebody joked earlier. This is a quick aside. No offense to my people, Kylie, love you to death, but this is a quick aside because I saw on Facebook a second ago. They said that teaching online is like watching Dora because the teacher just asks a question and then stares into space and then gives the answer. Like, what's the difference between primary and secondary succession? Right. Primary succession is when you have nothing, and secondary. I'm so sorry. But we just got to ask Boots. He'd be able to tell us. All right. So I don't know if I talked about it in this group. I think I might have talked about it in both groups. I can't remember. But there was a drive-in movie theater on the way to Kinston. They stopped using it, and the trees have grown all up, and you can't tell it was there anymore. That's secondary succession because the nutrients were there, everything was there for the ecosystem except for just allowing it to grow. Same thing with it, like abandoning a field or after a forest fire, secondary succession. Primary succession only happens when you start from nothing. So there's really only two ways that you can get primary succession. Getting new rock, which will be what? It's the only way you make a new rock. What did you say? Yeah, that's our science class. I'm not talking about that. What's the only way you're getting new rock? Like it's only happening in a few places on Earth where they're making new rock. Volcanoes. Okay? Volcanoes, and yeah, you could say sedimentary and compression, blah, 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 blah. I'm talking about new rock today. Volcanoes. You with me? Okay? So volcanic activity and then revealing old rock. Earthquake, you might be able to make an argument for it, but there's a bigger way that's happening, especially due to climate change and global warming. What moving off of rock? You're on the right track. Somebody, I think you both said it kind of together. Glaciers. Receding glaciers, revealing rock, and volcanic activity making new rock. Those are the two big ways that you can get primary succession on Earth today. Make sense? Which is faster? No. Which is faster, primary or secondary succession? Secondary succession is way faster. Primary succession is incredibly slow because what do you have to make? What's probably the most important factor that takes forever to make? That you need to grow trees and plants? Soil. Going from big rocks to little rocks. Absolutely. Okay? Callie just rolled out, got no love for us. All right. One thing, we kind of mentioned it in passing, but I didn't go into it too much. If you clear a field, what type of, in North Carolina, Eastern North Carolina, you clear a field, what type of trees do you expect to grow first? Clear a field and then leave it alone. Come back in 5 years, what type of trees do we expect to see? Not many birch trees in North Carolina. What did you say? Not oak trees yet. Pine trees. Go to any clear-cut forests that's been clear-cut in the last 10 years or so, unless it's like a swamp like in Grifton, and look out the window, you're going to see a bunch of pine trees. Come back in 40 or 50 years, then you have your oaks and your maples and things like that. Okay?
Don't pine trees the seed sprays in?
Well, they grow quicker. The tap roots grow quicker. I mean, it's just pine trees shoot up so much faster. Is that what you were saying too? Yeah, I mean, well, so do oaks and hickories. It's a slower growing species, but it is, once they take over, they kind of shade out the pine trees, and pine trees aren't able to grow. So if you go look at a forest that nobody's touched for, where we go to the edge of the woods over there where we found the red mulberry, if you go back 20, 30 feet into the woods where nobody's ever grown anything in the past 400 years, there's no pine trees. Because you have these giant oak trees that are just covering them up. Like my big giant oak tree behind my house that I showed you guys, there are pine trees under that thing because they can't get sun underneath it because it's just taking over that area. Make sense? All right, rolling on. Sure.
Whenever, if I go to make hot chicken or anything, the only thing that they plant is pine trees. Is that because they grow fast?
The only thing that who plants?
That people go to hot chicken
Probably. Probably has something to do with attracting deer and stuff.
I've ever been on, it's just old pine trees that are like 15 feet tall.
And it probably has to do with that and easier to, it grows quicker and easier to sell to warehouser. Like you get to a point in 30, 40 years where you can sell a whole bunch pine trees to warehouser.
They're planted strategically, like all in lines, like in rows.
Absolutely. And warehouser will come and pay you to cut them down and stuff. Yeah, absolutely. All right. We talked about biodiversity. Lots of biodiversity is good because when something happens, so like if you disrupt an ecosystem, why is having lots of biodiversity good? Yeah. So like both genetic diversity, having different genes in your species, and the biodiversity having multiple different species, life will find a way to get around it because strategies will probably exist in the community already to beat whatever your disruption is. Halfway there, guys. We already talked about that. Another one looking at a map and figuring it out. Holy mackerel, that question is easy. Mr. Sleeve maybe put this question on, it's too easy. What's a danger in having a monoculture? Like planting the same species of corn from the same seeds that you bought from Monsanto in the entire state of North Carolina. What's the danger of that? Well, it uses all the same nutrients, so it's dangerous. It can be rough on the soil. Go ahead, Cody. Yeah, okay, I'll buy that. What about a what if? What if a blight comes and kills my crop of corn? It's going to kill all the crops of corn because they're all the same. You know, if they grow good, great. They grow good for everybody. But if they grow bad, it's going to be bad for everybody. And so it's a really risky proposition to grow. And it's what we do in the United States. I think the percentage is something like 83% of all of the corn grown in the United States are one species, yellow dent number 2. I mean, it's wild, you know. And you think about it, prior to commercial agriculture, you probably had 1,000 different species of corn growing all throughout the United States. Rock and roll. All right, we talked about that. Coevolution. What is coevolution? Absolutely. You know, you can have good coevolution and you have bad coevolution. Good coevolution is, well, depending on your perspective, good coevolution would be like the honeybee that has evolved to see the flower and get food, and the flower that has evolved to attract the honeybee to get pollinated. Okay. Bad coevolution from a different perspective would be the rabbit that has evolved to be really, really fast and outrun the fox, but the fox that evolves in response to be able to be fast and catch the rabbit. Carry on. All right. We talked about competitive exclusion principle. If 2 species are in the same ecosystem trying to fill the same niche, what's going to happen? Let's say we're measuring. I don't know, it could be anything. How much oxygen level that these guys like. You have one species that really likes, you know, the lower end of the oxygen level, and so you have the species that exist like this. Let's go down to 0. And then you introduce a species that lives like this. Is that going to be able to stay like that? You got a whole bunch of species trying to enjoy the same amount of oxygen, right? So this competitive exclusion principle says if 2 species are trying to use the same niche, one of them's got to either die or change. And so whatever species is hardier is probably going to, you know, change the least. But over time, I'll do dotted lines. Over time, you'll probably end up with something that looks more like this. So you end up getting out of this zone where they're competing for the same thing and evolving in separate directions. Adaptive radiation, where if you say this is what happened with the finches. 2 finches tried to eat the same thing. Well, one started aiming for a different thing because they're able to survive better. And so over time, they became less and less alike because they were eating different things. But main thing is that competitive exclusion principle means that if you have 2 species in the same ecosystem, there's going to be as little cross as possible from those things. Now, they're not going to completely go, you know, overnight, way to opposite ends of the spectrum, and they'll probably still have a little bit of cross, you know, because you'll still have some born that are in that zone. But the smaller the zone of the smaller the zone of competition is, the more healthy the species. Another one, just to read the chart. We talked about keystone species. The one we talked about was a bat. Squirrels could maybe be keystone species here in North Carolina, but I'll be honest with you, honeybees are probably keystone species as well in North Carolina. If you go off the coast of California, there's a mammal that lives off the coast of California in the kelp forests that not only lives on the surface and affects kelp on the surface, but also dives down deep and affects ecosystems at the bottom of the ocean as well. Manatee, not on the West Coast. Manatee would be more on the East Coast, Gulf of Mexico, Florida, a little bit in North Carolina.
It says a mammal.
Mammal.
And it's like it's
in the kelp mammal in the kelp forests off the coast of California. Nah, dolphins are mammal, and there probably are dolphins, but dolphins don't exist as much on the surface. This mammal spends a lot of time on the surface, but also dives down and gets food as well. Seal spends a lot more time on land, but yeah, seal maybe be a keystone species in some ecosystems, but sea otters. Sea otters are huge. We're talking about the little guys who lay on their belly and take one rock, they get the rock and they crack the thing, and then they hold hands and they'll float away from each other. Yeah. What?
Those are more like northwestern.
Pretty sure they're off the coast of California, like in the kelp forests. I might be wrong. We'll check. We'll look it out when we're done. We'll look at it.
I didn't know there were any otters, like there were saltwater otters or sea otters. So I
yeah, sea otters.
I know there's like giant otters in freshwater.
Yep. I got a math question for multiple choice. Just kind of read it carefully. Another one, reading the chart. Same chart. Another question. Another question about tree succession. You know, it shows the early growth around here will be pines, but then later it will be your oaks and things like that. Read the chart carefully. Pines work really well because they work really well in full sunlight. That's why these pines out here by the road are so big and strong and beautiful, because full sunlight all day, every day, they grow. The shade tolerant trees that need a little bit more shade and require a little bit less sunlight, they're the ones that grow later. Okay. Once again, we already mentioned species richness. That's the most number of species. Species richness is just biodiversity where you're looking at number of species and nothing else. Evenness is where you're talking about the evenness of the species. Yep, we already talked about that. Yep, we already talked about that. And then I got one to just read and answer. Only a couple where you have to read a lot to get to the answer, but just make sure you read carefully and don't let it trick you. All right, the essay for tomorrow has to do with using data to answer questions about zone of tolerance, how ecosystem changes. It's kind of similar to the essay question that you did on the last test, where it gives you data and you have to make some conclusions based on that data, except for this isn't talking about biomagnification. The last test was all about biomagnification. This is all about, like I said, zone of tolerance. And so to me, it's pretty straightforward. It would be an essay question that you probably could figure out having never sat in AP environmental science class, but just make sure you use the terminology that's appropriate for some of the things we talk about, things like biodiversity, things like zone of tolerance, things like competitive exclusion principle, if it applies. I'm not sure it applies because I haven't read the whole thing perfectly. But I think it's a pretty straightforward essay. Same as all of your essays. It's 3 parts, and 2 of the parts have multiple parts themselves. So answer all the parts of the question. And then the big thing that a lot of people didn't do on the essay question on the AP test, APID test, if it says describe, describe. Okay, so for example, if the question says describe something on Tyre's desk, saying there's an ECU gnome on Tyre's desk is not enough. There's an ECU gnome with a purple hat and a grin on his face that looks like he might have just eaten your last lollipop. You understand what I'm saying? Describe it. Don't just be happy listing something for me. If it says describe, describe. If it says explain, not only do you have to describe, but you have to tell me, well, this is an ECU with a purple hat and a grimace on his face, and he exists on Mr. Tyre's desk because Mr. Tyre is an ECU fan. So you have to take it another step and explain why the gnome is here anyway. So make sure those key words, explain, describe, you really get a hold of. That's why one of the reasons they're up there. The describe isn't up there, but you know, those key words that you get a whole lot of questions in, we put those words up there so you really understand where you need to go on that. Get all the points. So right now, I'm looking at this question right here. I got an explain, I got a determine, I got a calculate, and then I got to describe. So make sure you know what the question's asking you to do and you do it. Any questions? All right, that's the test for tomorrow. Let's see if I can find something about the otters. I'm gonna let the folks go. Kylie wouldn't want to listen to me anyway. Sure.